Hello, welcome to my channel. In this video, we are going to be taking a look at moving balls in a perpendicular glide rail. And the problem we want to solve has a diagram of this form, right? And the question that arises from this diagram is giving us if the two balls X and Y are connected by a rigid rod of length Z and can slide easily along perpendicular glide rail. This is a perpendicular glide rail. What will be the speed of the ball y when theta equal to 55 degrees? So if you take a look at this diagram, this ball can slide along this particular rail, and as it slides, because they are connected to this other ball, it also affects this particular ball. So as this one slides along this rail, this one also slides in this rail. So let's take a look at some other labels that we did not include. So we have our x-axis, then we have our y-axis. So we assume that the distance from here to here is y, while the distance from here to here is x, right? So to solve this problem, the first thing we must consider is that the speed of this can be determined at any point in time. So what we want to find out is that when it is initially here, the position, we can call it x1. When it slides to a point somewhere here, it is called x2. So the speed of this ball x is giving us Vx equal to x2 minus x1 all over t2 minus t1. So we notice that the speed here is moving in this direction. So the final speed position, which is x2, is lesser than the initial position x1. So that makes this particular velocity a negative velocity, right? Okay, so if this is this, we can reduce this one to Vx equal to dx dt, and we can make dx stand alone, and that gives us Vx dt equal to dx. So this is the expression for the equation for this particular ball x. Now, if we also do the same for ball y, we have something of this form, Vy dt equal to dy. Now, we can connect these two by dividing this expression by this, and we have Vx dt all over Vy dt equal to dx dy. And this reduces to, since this one can take care of this one, we have this expression. Now, our aim is to find the velocity Vy in terms of Vx, which is known, because as this one moves, it affects this one. So the speed of this affects the speed of this one. So if we make Vy the survey formula, we have Vy equal to Vx dy, right? Okay, so there is another thing we also need to know, because this dy dx, we cannot just end here. We have to find a connection between this dy and the x in terms of parameters that are known. There's a connection between the x, the y, and the z, and which is giving us x squared plus y squared equal to z squared. So if we differentiate this expression, we have 2x dx plus 2y dy equal to 0, because this one is a constant, it doesn't change. So if we send this one back to this part, we have x dx equal to minus y dy. Now let's find dy dx because of this dy dx, and we have minus x all over y equal to dy dx. Now that we have established this expression, we can replace dy dx with x over y, since we know x over y. But at any point in time when the balls slide, there is a connection between x and y in terms of theta, and which is giving us tan theta equal to y all over x. Now, since we have y all over x, but we need x all over y, we can make x all over y stand, and that gives us x all over y equal to 1 all over tan theta, and we can introduce our minus here, so that gives us dy, right, dy dx equal to minus 1 over tan theta. Since we have established that dy dx equal to this expression, and this expression equal to this, therefore this one will be equal to negative of this expression. Now that we have our dy dx equal to minus 1 over tan theta, we can substitute here, and that gives us Vy equal to, remember that we said our Vx is a negative value. So it becomes minus Vx times minus 1 over tan theta. And with that, if we substitute the value of theta, we have Vy equal to Vx 1 over tan 55. And that gives us 0.7 Vx. That's it. I hope this helps. What I want you guys to do is to see what value of theta will make Vy have the maximum velocity. You can write that at the comment section and let's see if you are correct. Thank you for watching. Please like, share, and follow.